Welcome to GATE video. I am Dr.M.MEGANATHAN, Assistant Professor, Department of Mathematics, SA Engineering College. So in this lecture video, we are going to see the concept of complex analysis with analytic functions. So let us look out the definition of analytic function first. So what is analytic function? So in complex analysis, we know that Z equal x plus iy represents the complex number. So when we go for a function that represents as f of z, so z equal to f of x is a complex number and f of z represents the function of z. So that can be notated as u of x comma y plus I into v of x comma y. So f of z equal u of x comma y plus I into v of x comma y. So as we know, z equal to x comma y, x is a real part of z and y is the imaginary part of z. And in f of z, u of x comma y is a real part and v of x comma y is the imaginary part. So now let us see, any function f of z is said to be analytic function at a particular point z naught. So that is if it is differentiable at the neighbor points of z naught. So the another way to easily understand the concept of analytic function is a function f of z can be represented u of x comma y plus I v of x comma y, that can be said to be analytic function if it is satisfies the Cauchy Riemann conditions, that is ux equal to vy and uy equal to minus vx. So what is ux here is nothing but differentiation of u with respect to x, and what is vy here, differentiation of v with respect to y, and similarly uy is nothing but differentiation of v with respect to y and minus differentiation of v with respect to z. So as simply we can recall the concept, any function f of z is said to be analytic if it is satisfying this condition. Then we can conclude the function f of z is analytic function. Then another way, what is the definition of harmonic? In the same concept, we should know what is harmonic function. So harmonic function is nothing but a function in the function f of z equal to u of x comma y plus I v of x comma y. U of x comma y is said to be harmonic function, means that is u xx plus u yy equal to 0. What is u xx is differentiation of u with respect to x as second derivative, that is dou square u by dou x square, and similarly u y is nothing but dou square u by dou y square. So when we add both the differentiation, that is equal to 0 mean, then I conclude u is harmonic function, and similarly for v is harmonic mean vxx plus vyy equal to 0. So two definition is very important. Whenever we say f of z is analytic means if it is satisfies the CR equation, we can say f of z is analytic. Then f of z, in f of z, u is harmonic mean u double x plus u double y equal to 0. Now let us see some of the example. As first example we can look out. So in the question they given, we need to verify which of the following complex is or analytic on the complex plane. So the simple question, they given a 4 example here. I need to check which one is an analytic or not. I will choose the first one, f of z. So f of z equal to, they given j into real part of z. So what is real part of z is nothing but x. So j into x. So z equal to x plus iy. Then real part of z is x and imaginary part of z equal to y. So from that we can choose real part of z as x. Therefore our f of z equal jx. So I said any function f of z is analytic, mean that is returned in the form of f of z equal u of x comma y then plus I into v of x comma y. This function is analytic if ux equal to vy and uy equal to minus vx. If it is satisfied this condition, we can say that function f of z is analytic. So I need to verify now f of z equal to jx is analytic or not. So now what is u of x comma y? In our example there is no real part in this f of z, therefore that is equal to 0. So what is imaginary part? We conclude instead of I we have j here, so that is v of x comma y is x. So I will find out what is ux, that is differentiation of u with respect to x is ux is 0, because already u is 0, therefore ux also 0, and similarly what is the differentiation with respect to y? uy equal to 0. And now what is vx? So vx equal to 1, so v of x comma y equal to x, vx equal to 1, so that then vy equal to 0, there is no y, therefore the differentiation is 0. Now from this I can say ux equal to vy, because ux equal to 0 and vy equal to 0, but uy equal to minus vx we need to get, but uy 0, vx is 1, they are not equal. Up uy is not equal to minus vx, therefore this function is not analytic. This function is not analytic. So similar way we need to go for the next one. So as like the first one f of z, now I need to verify this f of z equal imaginary part of z. How we can write this one? F of z equal imaginary part of z is what? Simply y. So from this what is u of x comma y? Will get 0. That is will get y. So real part is y, and what about imaginary part? That is v of x comma y equal to 0. So similar way one function we can get variable, the another function v of x comma y is 0, therefore we conclude this is also not analytic, because similarly we will get ux is not equal to vy, so therefore we conclude this function is not analytic. Then we will go for the third one, f of z equal. So what they given? F of z equal e power modulus z. So modulus z can be written in the form of e power root of x square plus y square. So similar way here also you will get, there is no imaginary part. So what is your u of x comma y in this equation is as it is root of x square plus y square. What is your v of x comma y? That is equal to 0. So again we will get one function as variable, another function is 0. So definitely this is also not satisfying the CR equation. Then we conclude this function is also not analytic. So now we will go for the last one. So the last function is f of z equal. So f of z equal z square minus z. So what is z? We represents x plus iy that whole square minus of x plus iy. So we substitute simply what is z equal to complex number x plus iy. So now I will expand using a plus b whole square, that is a square minus 2ab. Therefore, plus 2ab, that is 2I into xy, then plus b square. So plus iy square minus 1, therefore minus y square. This we can write minus multiply inside minus x minus I into y. So simply I expand a plus b whole square, this we will get. Now I can separate the real and imaginary part. So x square is a real part and minus y square is a real part and minus x is also real part. And wherever I will take commonly outside. Then from I it goes outside, mean we will get 2xy, then here minus y. So now our f of z. So they given f of z equal z square minus z. Now I simply substitute z equal to x plus iy. F of z equal, I separate the real part and imaginary part. So when I compare with our definition, I will write what is u of x comma y. So u of x comma y equal x square minus y square minus x. And similarly we can write the imaginary part, that is v of x comma y, that is equal 2xy minus y. So now I need to verify whether it satisfies the CR equation. So I need to find out what is differentiation with respect to x. So ux is nothing but, so x square differentiation 2x, then there is no x, so you will get 0, then x differentiation as 1, then 2x minus 1, so this is our ux. And similarly what is uy equal to differentiation of y, so 0 minus y square differentiation 2y, then there is no y up 0, that is equal to minus 2y. Similarly, we can find out what is Vx. So Vx equal differentiate with respect to x. So 2y minus 0. So that is equal to 2y. And what is Vy differentiation? That is 2x minus 1. So now I need to verify the CR equation. Ux equal to Vy. So I get 2x minus 1 here, and here also 2x minus 1. And Uy equal to minus Vx. So Ux equal to minus 2y. Here minus into 2y we will get. Therefore, the CR equations 2ux equal to Vy and similarly Uy equal to minus Vx. So the concept is any function f of x, if it is satisfying this CR equation mean, then I conclude this function f of z is analytic. So therefore the final f of z equal to z square minus z is our analytic function. So this is a simple example. Now we will go for a next example. So here they given the value of k that makes the complex valued function f of z equal e power kx minus kx into cos 2y minus I into sin 2y is analytic, where z equal to x plus iy. So what is my aim in this problem? They given this f of z is analytic function. So when it makes for the value of k, we need to find out. So they given already f of z is analytic mean I know the definition. So any function f of z in the form of u of x comma y plus I into v of x comma y means if it is analytic, we conclude ux equal to vy and similarly uy equal to minus vx. So this is the definition of analytic. So I can use this ux equal to vy and uy equal to minus vx to find the value of k. So they given f of z is e power minus kx. I can multiply inside e power minus kx into cos 2y minus e power minus kx into I into sin 2y. So the given f of z is this function. So from this I will write what is real part. Real part is our u of x comma y. So u of x comma y is e power minus kx into cos 2y. And what about imaginary part? The coefficient of I. So that is v of x comma y, that is equal minus e power minus kx into sin 2y. So from f of z, I separated what is u and v. So now I will find out what is ux. Ux is the differentiation of u with respect to x. So I will differentiate this one. So the differentiation of e power minus kx as it is e power minus kx, and the coefficient of x will be in multiplication. So minus k. So into cos 2y. And similarly I will find out what is uy equal to differentiation of y. So e power minus kx as it is differentiation of cos 2y sin 2y minus sin 2y into 2. So that minus 2 I will write in front. And similarly I will find out here what is vx. So vx equal to x I will differentiate. So e power minus kx, then minus k will come. So already one minus, therefore it will become plus into sin 2y as it is. Then what about vy? So I will find out vy differentiation with respect to. So minus e power minus kx as it is differentiation of sin 2y cos 2y into 2. So the given f of x can be separated into u and v of x comma y. So now I find out ux, uy and vx, vy. They given already this function is analytic. So therefore analytic mean what? This condition will satisfy ux equal to vy we will get. So I equate both. What is ux? Minus k e power minus kx then cos 2y. And similarly what is vy? Minus e power kx then cos 2y into 2. So both side cos 2y will get cancelled and e power minus x, e power minus l will cancel and minus and minus will cancel. So k as it is will be here and here the constant only remaining. So k equal to 2. So this is our aim to find. So the given this function is analytic for what value of k we need to find. So I use the CR equation and find the value of k equal to 2. Therefore this is your answer. So likewise we can see the next example. So in this question they given which of the following complex function are not analytic. So we need to verify which one is not analytic. The same way you can go for f of z equal to z square. So what is z? We know that z equal to x plus iy. Therefore f of z equal, I will conclude x plus iy that whole square. So I will square a plus b the whole square formula I am using. So x square plus 2ab, therefore 2 into I into xy plus b square, therefore minus y square. So as per the previous example we can separate real and imaginary part. So real part is x square, here y square. So x square minus y square, and here we can write I into 2xy. So this is our f of z. So the first function they given f of z equal to z square. I substitute simply x plus iy as z. Then I can expand a plus b whole square formula. Now I separated real part and imaginary part. So from this we can write what is u of x comma y is the real part of f of z. So real part is x square minus y square. And what is imaginary part? V of x comma y. The coefficient of I is our imaginary part. So that is equal to xy. So what is my aim? I need to verify this function is analytic or not. So therefore I separated u and v. I need to verify the CR equation. So I will differentiate ux, that is equal to differentiation of x square minus y square is 2x. And similarly I will find out uy. So uy equal to minus 2y. And similarly here you can differentiate vx, that is equal to y. And what about vy? That is equal to x. Therefore I conclude here the CR equation ux equal to vy. So ux is 2x and vy is 2x. Both are same. And similar way uy equal to minus vx. So here minus 2y then minus into vx. So that is also satisfied. So I conclude this function is analytic. So similar way you can check every function. So f of z equal e power z and f of z equal sin z, and finally you will get f of z equal to log z is not analytic. That means that is not satisfying this CR equation. So as very simple, the concept of analytic function is any function f of z is can be given in the form of u of x comma y plus I into v of x comma y. Means if it is satisfying this CR equation, then I conclude the function is analytic or else not analytic. Now we can go for, this is the concept of analytic function. Now I will go for the next one is harmonic. So another definition I given in the beginning is the concept of harmonic function. So what is harmonic? So I will recall again the definition. So any function f of z u of x comma y plus I into v of x comma y means if u is said to be harmonic, that u of x comma y is said to be harmonic means I can differentiate u with respect to x as 2 times, and similarly differentiation of u with respect to y 2 times. When I add these two answer, if it is equal to 0 mean then I conclude u is harmonic function. And similar way, when I say V is harmonic mean, that is Vxx plus Vyy equal to 0 means, then I can say V is harmonic function. So what they given here, which of the following is not harmonic function, we need to find. So they given u of x comma y equal to x square plus y square. So I need to verify whether this is harmonic or not. So I need to find out, they given u, so therefore I will find out uxx. So I will take that function as it is, u of x comma y equal, they given x square plus y square. So I need to find out the first derivative ux. What is the differentiation of u with respect to x is 2x, x square differentiation 2x, there is no x in the second term, therefore 0, so that is equal to 2x. So I need to find out uxx. I will go for the second derivative also, that is uxx. So differentiation of ux with respect to x again. So therefore 2x differentiation I will get 2. So similar way I will find out what is uy. So uy equal to 2y I will get, and similarly uyy, the second derivative as it is 2. Now I will add this uxx and uyy. So what is uxx is 2, and what is uyy, that is also 2. So therefore I will get 2 plus 2 equal to 4. But what is the definition? U is harmonic means uxx plus uyy equal to 0. Therefore when I add I will get answer as 4. Therefore I conclude this function u is not harmonic. This function u is not harmonic function. The reason is when I add I will get answer as 4 if I not get 0. And similar way you can check x square, because they given which of the following is not harmonic function. So I found this is not harmonic, therefore this is your answer. So this is the concept of harmonic function. Let me look one more example for this. So like this example they will ask in examination, because this is very useful. So in the question they given, what is the value of m for which 2x minus x square plus m square is harmonic? So they given this function is harmonic mean, what is the value of m? I need to find out. So I will take this maybe as our u of x comma y. So that is equal 2x minus x square plus y square. So they given this function is harmonic. Harmonic mean what? That is uxx plus uyy, that is equal to 0. So therefore I will differentiate u with respect to x as 2 times. So first I will find out ux. Ux is what? 2 minus 2x plus 0. Therefore that is equal 2 minus 2x. Then what is the differentiation of ux? X. So that is equal, again I will differentiate ux with respect to x. So therefore that I will get minus 2. Then similar way I will find out uy. So what is differentiation of u with respect to y? So there is no y in the first term, there is no y in the second term, that is also 0, and here we will get plus 2my. So y square differentiation. So that is equal, simply the answer is 2my. Similarly, I will find out what is u double y. I will differentiate uy again with respect to y. So I will get 2m. So the y is 1. So that is equal to 2m. So u is harmonic means uxx plus uyy equal to 0. So I found already uxx equal to minus 2 and uyy equal to 2m. So I will add both the value, that is minus 2 plus 2m, that is equal to what? 0. Therefore 2m equal to minus 2 goes mean plus 2. Therefore m equal to 2 by 2, that is equal to 1. So the value of m is 1. So that's what they ask. So what is the value of m when this function is harmonic? So I use the harmonic condition as uxx plus uyy equal to 0. Therefore we will get m equal to 1. So in this lecture what we learn, the two idea is, one is analytic function, the another one is the concept of harmonic. What is analytic? As simply any function f of z equal u of x comma y plus I into v of x comma y is said to be analytic mean if it is satisfy CR equation, that is ux equal to vy and uy equal to minus vx. and similarly in this function u is said to be harmonic mean, that is uxx plus uyy equal to 0, and similarly v of x comma y is harmonic mean, that is vxx plus vyy equal to 0. So we seen some simple example like this only. We will get any one or two question in our engineering mathematics syllabus for GATE examination. Okay, thank you. We can continue in the next class for remaining topics.